Good evening, Titans. And this evening we're going to discuss operations with radicals. Specifically, we're going to be multiplying and dividing radicals. So, operations with radicals. The essential question: how do I multiply and divide radicals? And again, we say radicals, but we're always going to be multiplying and dividing square roots. The multiplication property is often written: the square root of a times the square root of b is equal to the square root of a times b. Now, we can also write it the other way: the square root of a times b is equal to the square root of a times the square root of b. It can be used both ways, and we use it both ways many times. The nuts and bolts of this: to multiply radicals, we will multiply the coefficients, which are the numbers on the outside of the radical sign, and then we will multiply the radicands, which are the numbers on the inside, and then simplify the remaining radicals. So for example, if we look at this first one here, we have the square root of 5 times the square root of 35. So there are no numbers on the outside, so we take 5 times 35 and leave it underneath the radical, the square root of 175, and then we simplify it. Now obviously we could take 175 and do the factor tree, and we know that 5 goes into that 35 times, and then 35 is 5 times 7, and we have a pair of 5s, which is why we pull the 5 out to the outside, times the square root of 7. Or we can also use just that 25 is the perfect square root factor of 175, and also simplify it to 5 times the square root of 7. Now this is one that's a little bit more like the directions stated. We have 2 times a radical 8, or 2 times the square root of 8, times 3 times the square root of 7. So we're going to multiply the coefficients, 2 times 3 to get 6, and we're going to multiply the radical part. Square root of 8 times the square root of 7 is the square root of 56. But now again, we have to simplify the square root of 56. So again, if we use the factor tree, we have 8 times 7, 4 times 2, 2 times 2. So we have a pair of 2's, which is why we have a 2 on the outside. And then 2 times 7 doesn't pair up, so it stays 14 underneath the radical. And we multiply the two outside numbers together, and we have 12 times the square root of 14. And again, sometimes students will say 12 radical 14, which is acceptable, but typically we would like to use the square root terminology. And this last one, we have, again, coefficients that we're going to multiply. 2 times 4 is 8. And then we multiply the radical parts. Square root of 5 times square root of 20 is the square root of 100. And again, if you're able to recognize that the square root of 100 is a perfect square, then there's no need to use the factor tree. And we have the square root of 100 is 10, so we have 8 times 10, and your answer is the whole number, 80. So that's really the nuts and bolts of multiplying radicals. We'll do some more things with it than just this tomorrow in class, but this is the basic method of multiplying radicals. Now, if we look at a radical that's squared, understand that the square root of 5 squared, those are just really inverse operations, but also the square root of 5 squared means the square root of 5 times the square root of 5, which is the square root of 25, which is obviously just the whole number 5. The square root of 7 squared is the whole number 7. The square root of 8 squared is the whole number 8. So really, the square root of any number squared is just that number. So, trick question: is there a number in front of the square root of 7? Well, is there a number in front of x? The answer is 1. Just as there is a ghost 1 in front of the x, there is also a ghost 1 in front of the square root of 7. And so that's 1 times the square root of 7, but again, we just read it as the square root of 7. Now we're going to move on to dividing radicals. And the first thing is, again, the related property states that square roots are also distributive over division. So the square root of a divided by the square root of b can be written as the square root of a over b. It can be the square root of the fraction equals a fraction of square roots. And we'll use this idea to divide radicals. So again, the base idea to divide radicals is to divide the coefficients, which are the numbers on the outside, if you can, and then divide the radicands, the numbers on the inside, again, if possible, or at least reduce them if you can. And then rationalize the denominator so that no radical remains in the denominator. And this is a topic that we'll discuss here in the next couple. So first, the square root of 56 divided by the square root of 7. Well, if you notice, we could have rewritten this as the square root of 56 sevenths using the property. And 56 divided by 7 is 8. So we actually end up with the square root of 8, and then we have to simplify that. Well, again, if we use the factor tree for 8, that's 4 and 2, 2 and 2, and so there's a pair. So again, the 2 goes on the outside with 1, 2 remaining underneath the radical. 2 times square root of 2. Now, in this case, we have the square root of 6 over the square root of 7. And 6 sevenths cannot be reduced any further. But one of the major rules of simplifying radicals is that we cannot have a radical in the denominator. Well, if you remember the previous slides where we took the square root of a number times the square root of the number, and that was equal just to that whole number. Well, we want to use that idea to help get rid of the radical in the denominator. So we're going to multiply the fraction times the square root of 7 over the square root of 7. And the reason we do that, because that's like multiplying it by 1, so it doesn't change the value of the fraction. But it then also allows us to get the square root of 42 on top over the square root of 49 on bottom. And again, the square root of 49 is the whole number 7. Now, typically, we would just go right to this answer. 42, if it could be simplified, we would have to do so. But since if I do the factor tree of 42, we have 2 and 21 and 3 and 7. We have no common prime factors, so there's square root of 42 cannot be simplified. So my final answer is the square root of 42 over 7. One major thing we have to remember is that we can never divide a number outside the radical with a number underneath the radical. If we look at this example here, well, the square root of 5 over the square root of 10. We can first reduce that to the square root of 1 over the square root of 2. Now, square root of 2 cannot be simplified, so we're going to have to rationalize that denominator. So we have to multiply the denominator and the numerator by the square root of 2. And then square root of 1 times square root of 2 is the square root of 2. And the square root of 2 times square root of 2, if we recall, is just the whole number 2. And again, there's your final answer. We cannot reduce that because you can never reduce a number outside the radical with a number under the radical. And now, our last example. We have 3 over the square root of 12. Well, obviously, I cannot reduce 3 and 12 because one's outside the radical and one is underneath the radical. Now, they're kind of being creative here because what we need to do is make the denominator a perfect square. Well, 12 times 3 gives us 36, which is, again, a perfect square. But we might have ended up doing this by taking 3 over the square root of 12, and maybe you just would have multiplied top and bottom by the square root of 12 right away. And then you would have had 3 times the square root of 12 all over 12. But now the issue is I have to simplify the square root of 12. And so now I do 12 is 2 times 6, 2 times 3. Again, there's a pair, so that goes on the outside. So on top I have 3 times 2 radical 3 all over 12. And 3 times 2 is 6 radical 3 all over 12. And now I can reduce the outside numbers. 6 goes in there once, 6 goes into 12 twice. And so I end up with the square root of 3 over 2. Again, a couple different ways to get to the same answer. Again, knowing that you can multiply the square root of 12 times the square root of 3 to get to the square root of 36 is, a shortcut. But it may not be the most viable method that you would choose to use. So, again, the example that I showed over here might be your best option. Now, we will continue to work with multiplying and dividing radicals tomorrow in class. But again, I hope you have a good base. Hopefully you were able to pause. You may want to go back and look at a couple of the examples to have in your notes. And we'll again discuss this a lot more tomorrow.
Made with Doodlecast Pro.